What is an RCT? You've probably heard the term RCT a few times, especially in the field of academic research and/or evidence-based policing. Commander Alex Murray used it a lot in his Dr. IPEP interview on evidence-based policing. But what is an RCT? In essence, it is the most robust and reliable way of carrying out research that tests something. RCT stands for randomized controlled trial. Now, you might think the terms random and controlled might sound as if they don't really belong together, but it will become more obvious in a bit how they are connected. The control bit. Let's start with a basic example. When you want to test the effect or impact of something, you obviously need to give it a try and look at the outcome. If this attempt then leads to a specific outcome, can you automatically say that it's down to that new thing that you tested? Not necessarily. You need to be sure that there was no other potential factor that could have influenced the outcome. For example, if you try a new way of dealing with drunken customers when the bars and clubs shut on the weekend and you have fewer issues, this could be down to the new technique of handling intoxicated people that you trialed. However, can you be sure that it's not because of there being fewer people out that weekend? Or maybe the local football team had a great win and people are happy and behave better. Or maybe the team lost and people are depressed and withdrawn and interact less. Or the weather was such that everyone avoided the outdoors and quickly made their way home, rather than congregate outside in groups with other intoxicated people. And do you even know if your new technique was applied by everyone who was supposed to trial it in the way they were supposed to be using it? What if they thought from the outset it would not work and did not employ it? What if some applied it more consistently and with more enthusiasm than others? The more you think about it, the less you can be certain that the outcome you measured is because of the new way of doing things that you wanted to test. This simple before and after design is not very robust, and whilst it is a great start, it does not give you certainty of your new method's effectiveness. This is why experiments need to be controlled. You need to be aware of all the potential outside influences or variables that could have an effect on your outcome. Once you are aware of them, you can try to control them. What you want to achieve is to be as certain as you can be that your new technique or process or piece of equipment, whatever it is that you're testing, is the only thing that could have caused that difference in results before your technique or intervention and after. The thing you are testing should be the only difference between the business as usual or the control group and the new thing, the experimental group. So let's control our variables then. We would want to make sure we had roughly the same amount of people participating in the nighttime economy on both occasions we took measurements. Once with the usual technique, control, and once with a new technique we want to evaluate, experimental. We want to take our measurements on roughly average weekends, not those that had any major events or anything unusual about them. We want to make sure the weather is roughly the same, etc. That is why you can't compare certain measurements taken in the summer to some taken in the winter. You usually get a lot more outdoor incidents when it's hot outside than when it's cold, because you'll have more people outside when the weather is good. Especially during weekends and school holidays, when more people have the opportunity to offend. The randomized bit. Another important thing you need to keep in mind when comparing a different technique or piece of equipment to the current one is how participants, in this case officers that use either the new or the old technique, are allocated into the two conditions. These conditions are either the experimental group, which is the new thing that is being tested, or the control group, which is business as usual. Let's say we want to compare a new piece of technology that could replace an older way of doing things. You need to make sure you don't bias the two conditions or groups you're comparing. If you let your participants choose which group they might want to be in, you'll find yourself with a lot of biases across your two groups. It is possible that those volunteering to try the new piece of equipment are already more tech-savvy and might use it much better than those who volunteered to keep using the old equipment would have done. So we're not only testing the equipment anymore. Our results are now being influenced by external factors or variables, such as the participants' skill in using technology. And skill is not what we wanted to measure. It is also possible that those who volunteer are younger and already opposed to the current, more old-fashioned method, and therefore might prefer any alternative equipment to the current way of doing things. This could affect how they use the new or old equipment, and we did not set out to measure how the equipment is used, but how good or useful it is. Of course, you will always get differences in participants. These differences might be their age, gender, intellect, interest, skill, and many other things. People are not identical. So, in order to make sure that these differences between individuals do not have an impact on your findings, you do not let the participants choose which condition they are in. Neither should you choose, as you might have your own bias. For example, if you hope to show that the new technology is better than the old one, you might, consciously or subconsciously, choose participants to use it that might be better at using it than others. That's why you randomly allocate participants to the conditions you're comparing, so that you can control for those external variables amongst others. And by controlling for, I mean making sure that all other variables that could have an influence on the findings are roughly evenly distributed between your two conditions, by allocating people randomly to one or the other. Then, if you have enough participants, individual differences between them should not have an impact on the outcome measures, as you should have roughly equal numbers of any differences across both groups. You should not be able to find that one group is smaller or bigger than the other one. The officers should have roughly the same gender and age distribution, roughly the same amount of policing experience, intellect, and command of the spoken language. How do you ensure that? You don't actually need to measure your participants on each of those factors or variables. You accept that they differ on these counts. But you need to ensure that this does not really impact what you're measuring. So how do you ensure that? Again, in order to control for all those variables, you make sure you randomly allocate participants to either one group or the other. In an experiment, the only difference between the conditions you are comparing should be your intervention, that new thing you want to measure. Otherwise, you cannot be certain that any difference in results is actually down to what you're trying to measure, and not some other variable, such as participants' experience, their interest in or aversion to using new technology, or their ability to articulate themselves, for example. And remember, the more participants you have, the more robust your results are going to be. RCTs should usually be conducted with a minimum of 200 to 300 participants. If you can get the help of academia, go for it. The more robustly the RCT was conducted, the more powerful the results will be. So, main points about how to design an RCT. 1. Use random allocation to either the experimental or control group to reduce the risk for bias and other factors than the one you're measuring. 2. Use as many participants as you can get, preferably at least 200. 3. Try to control for, as in keep constant, i.e. roughly the same, all other possible factors that could have an influence on your measurements. This could be the time of day, time of year, weather, the amount of people involved, etc. In essence, a randomized control trial does that. It randomizes participants into its different conditions to control for what might have an influence on the results. Ideally, we want to be as confident as we can be that if there is a difference between the groups, it is probably down to the intervention, i.e. the thing we were measuring, and not other potential factors. The thing you're testing should be the only difference between your groups. Only then can you state with some confidence that the difference in results is probably down to the thing you compared against status quo, as that was the only difference between the two groups you compared. Because of this, randomized control trials are the gold standard of research and carry the most credibility. Thank you for watching. I hope you found this content useful. You can get access to each episode's transcript with key learning points, timestamps and references if you get yourself onto my mailing list. Just go to the main EBP Doctor website on ebpdoctor.com, and on the bottom of each page you will find a sign-up form for notifications of new content. Just enter your first name, your preferred email address and the type of organization you work for. You will not get any spam. This is just for me to let you know about new content and for you to get access to all the transcripts.